Okay, let's get started with some more LeetCode, and I will try to keep better track of what I've worked on today and try to be a little bit more systematic. So we're gonna do 3 easies, 3 mediums, and 3 hards. So let's look at the problem list. And we'll find the first easy that we have not done yet. Okay, we have 3 right here. Remove duplicates from sorted array. Okay. Okay, so given an array of numbers sorted in non-decreasing order, it's an interesting way of saying increasing order. I guess it's not necessarily increasing order if 2 cells next to each other are the same. Remove duplicates in place such that each unique element only appears once. The relative order of the elements should be kept the same. So in place means we need to update the exact same array. Consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements. Oh, interesting. Return the number of unique elements. It seems like we have to do 2 things then. We need to remove the duplicates in place, and we also have to return the number of unique elements. The first k elements of nums should contain the unique numbers in sorted order. Okay, I see. Okay, so pretty much we will have to say const k, I guess, or let k to keep track, and we're just gonna return k. And basically we need to go through each element, and since they're sorted, we just need to look at the element next to it. If they're the same, then we basically don't need to increment. Instead, we need to swap it with the thing to the right to bring it over. We might actually have to we might have to actually bubble it up all the way to the end. Yeah, I think we have to bubble it up all the way to the end. So I think we can skip the first one. So we do 4. Can we skip the first one? Because in that case, k would be 1. Well, we know that we're going to do a loop. We just don't know how far that loop will go. I wonder if we should call this length, call this nums.length, and we go up to length, and that this would be nums.length. This would be length, and then rather than increment it, we'll decrement it. That way, if we never enter this loop, it will be correct. If we do enter this loop, we're basically finding exceptions, and we're trying to remove elements, essentially. So we can start at 1. And we'll just kind of keep it simple. It should be I minus 1. It should be I. I'll say if A equals B, then we need to take B and put it, just move it all the way to the end. J equals I. I is less than length. J plus plus. And we don't want to go all the way to the end. We just want to say we don't even need to really move. Yeah, we don't really need to move the number to the end. We just need to move all the numbers to the beginning, really. So num sub I, sorry, not I, j, equals nums sub j plus 1. Basically just move everything over. After that, we could say length minus minus, and we can say I minus minus, because now that we've moved everything over 1, we don't need to increment I. So this actually counters out the increment of I. So if we think about the complexity of this, this is big O n squared. This is an easy problem, so we're probably going to end up with n squared, but let's just see if we pass any of the test cases, because that would tell us whether we understand the problem or not. So we're out of memory. So the only way we're out of memory is if there's an infinite loop, because we wrote the wrong variable. Okay, at the very least, it seems like we've understood the problem. We can submit it and see where we end up on the leaderboard. And we did do terribly. Okay, so this is what I'm thinking now. We don't need to move everything over the way that we are. So how do we optimize this? This is n. This is n. So we don't necessarily want to do this bubble every time we find a match. Basically, you want to have like a let insert at 0, and basically we don't do this. The idea is we're keeping track of where we want new unique elements to go. So if A equals B, A is not equal to B, then we'll say nums sub num sub insert at equals. So like the first thing is guaranteed to be unique. So I feel like this should be 1. And this should be B. And if we've inserted, then we need to increment insert at. Else, I think the length decreases. So pretty much if we find a unique thing, then we insert that unique thing at whatever index we're at, increment that index. If it's not unique, we're still gonna go to the next thing, but we're gonna say that we have 1 less item than we used to. So that's an optimization. Let's see if it even works. So we got 1, 1. Oh, and that's because, so we need to see not if it's not equal to or are we inserting the wrong thing? So let's step through it. 1, 1, 2 is nums. Oh, hi Tofu, the Lofu. Yes, I'm coding. How's it going? I hope that you can see me coding. Cool. So it seems like we're pulling in the 1 when we want to pull in the 2. So let's run through this code manually. Length is going to be 3. Insert at is going to be 1. Should this be 0? I think I guess to keep things simple, we could no, because we do -1. We have to do 1. Okay, so I is 1. A is 1 because that's I is 1, -1 is 0, num sub 0 is 1. And then B is also 1. We can invert this logic for now. So is A equal to B? It is. So we just decrement the length. So when we decrement the length, we end up with length 2. And then we go to the beginning here, we do I++, so I becomes 2. Is I less than 3? But now length is 2. Okay, so I think we can still go to nums.length here. And then A will be 1, B will be 2. Are they equal? They are not equal, so we say nums insert at B, or nums insert at is 1, and B is 2, so this would become 2, insert at will become 2, and then we're done. So we can run this, see if we get a good result. We do. We can submit it. So we were at 264 at 5.16%. Should be a lot better. Okay, well, we killed it. So we can get rid of these helpers here. Submit it again if they will allow us. We get 100% again, which is great. Let's look at another person's solution. Okay, so they go through each item. Num sub I equals. So there's like this counter. They're doing something similar. But so they made a certain assumption. Let's see if that is an assumption that I made. Go to description. Okay, so there's always at least one item. So my solution actually considered that there could be 0 items. Their solution does not. If I were to have considered that items are always 1, then yeah, I wouldn't have needed insert at, or sorry, I wouldn't have needed length, and I could have used insert at as the length. So reading the constraints is pretty important in this case. Okay, that's easy. That's one of the easies.